Hello guys, so this video is the first of the series ng ating lectures on tests concerning two means. So bali, ang series consists of three videos or three lectures. Ang first nga is ito, this is all about population versus sample. Yung pangalawa will be all about two independent groups. Yung pangatlo will be about correlated samples. So ano itong population versus sample? So let's say meron tayong dalawang sets of data. Yung first set is all about the population. Kumbaga may data, particularly may mean and standard deviation about a population. And then out of the population, meron tayong maliit na group which is our sample. Okay, then our sample has also its own set of data. Merong mean and standard deviation. So we want to compare if the population na set of data is significantly different dun sa ating sample na set of data or the other way around. So we want to compare kung may difference ba or wala yung data ng population against our data ng sample. Okay, so this video will be focused all about population versus sample or the test concerning yung dalawang data set natin, ang population and the sample. So specifically, we will discuss first yung what is hypothesis testing or the different steps in hypothesis testing. Number two, yung rules of decision. Okay, this is very important because we have to decide kung may significant difference or wala yung ating dalawang sets of data. Then number three, yung ating specific na mga test. We have Z-test and the T-test. And then lastly, we have some sample problems. Okay, so ano ang different steps ng ating hypothesis testing? Number one, or the first step, the statement of the null and the alternative hypothesis. Okay, so meron tayong dalawang hypothesis, which are the null and the alternative. Okay, so sa succeeding slides, we will discuss that on detail pa. Bali, as an overview, yung ating null, ito yung statement na gusto nating i-debunk or i-falsify or ayaw natin na mangyari. Kaya gusto nating i-change. Yung alternative naman is the alternative. Yun yung gusto nating ma-achieve. Okay? Then step 2, state the level of significance. So either 0.05 or 5% or 0.01 or 1% yung ating mga levels of significance. So the best way of understanding the level of significance is we could view or see that as a degree of precision. Kung gaano kalaki yung margin of error ng ating study. Let's say 0.05 or 5%. So we could say na 5% yung margin of error ng ating study. So ang 0.01 mas strict, that is 1% na error, kumbaga. Okay? So, most of our studies are nasa 0.05, medyo mas relax o hindi ganun ka-strict. Ang mga medical studies naman or napakalaki ng effect ng maliit na error is nasa 1% or 0.01 yung ginagamit na level of significance. Mas strict kasi yung decision level pag nasa 0.01, no? Compared with the 0.05. But madalas ng mga studies sa sciences are nasa 5%. Okay? So yung mga medical studies or mga mas strict ang level of decision making is nasa 1%. Then number 3, determine the critical region. Later on, once we do the problem solving, we will be drawing or magdodraw tayo ng standard normal distribution, yung bell-shaped na curve. And dun sa ating bell-shaped na curve, we will be shading or drawing ang part na acceptance or rejection. Yun yung tinatawag natin na critical value. Okay? So, dun sa curve natin, makikita kung i-accept ba or hindi or kung paano tayo mag-decide. Okay, number 4, compute the statistic. Okay? So, yung ating computational na part, so we have to compute yung ating value na gustong i-compare sa ating mga hypothesis. And lastly, accept or reject. So ito na yung ating decision na part. So we have to accept or reject yung ating null na hypothesis. Okay, so what is a null and what is an alternative hypothesis? Okay, ang null hypothesis is denoted by the symbol na h sub o or h sub 0, and it is a statement that is under investigation or being tested. Ito yung gusto nating i-test na statement. And normally, yung ating null asserts no change. Walang pagbabago. Okay? Kumbaga, ang null hypothesis is the status quo. Kung ano ang condition ngayon or ano ang event ngayon, yan yung ating null hypothesis. And normally, it is the hypothesis we hope to reject. Gusto nating i-reject. Because nga, the purpose of a research or study is to improve or to introduce changes or improvements. Okay? So yung ating null is a statement of no change. Kung ano ang ngayon, yun pa rin siya. Okay? So we want to reject that because we introduce something new or we introduce an innovation or we want uh, to assert something na bago. Okay? So that's why yung ating null hypothesis is the hypothesis we want to reject. Okay? So assuming no or example dito, yung ating null hypothesis sinasabi na 15 minutes yung average time ng mga teenagers. Okay? So ito yung present na condition, nasa 15 minutes lang yung present na study time. Okay, yung alternative hypothesis, this is the research hypothesis. Ito yung ating alternative or bago na hypothesis. And this is what we want to accept. Okay? Because yung ating null is the present condition. And once we do some research, we want to introduce some changes. Okay? So that's why yung ating alternative is the research. Because that is what we want to we hope to accept or nagbago sa ating present na condition. And this is denoted by the symbol H sub A. This is a statement you will adopt in the situation the evidence or the data is so strong that you reject the null hypothesis. And this is the hypothesis nga that we hope to accept. Yung kanina, okay, sa ating example sa null hypothesis, equal to 15 minutes because this is the present condition, equal to 15 minutes. Ang mga possible na alternative dyan, pwede greater than 15 minutes. Okay, other books, anyway, are using the symbol na 1. But in this case, we will have yung H sub A for alternative. Okay, so going back sa example, pwede greater than, mas malaki sa 15 minutes yung study time, or pwede rin naman less than. Okay, less than 15 minutes yung study time. Or if we do not want to be unidirectional, or greater or less than yung ating decision, so we could say na not equal. So kumbaga mas liberal, no, because we have two possible options later on, kung greater than or less than. Okay, so normally yung ating null hypothesis is a statement of no change or may equal sign siya. So normally equal siya because equal is equal to the present condition. Kung ano ang nangyayari, that is equal to that. So yun yung ating null hypothesis. And the alternative will be either nagbago. So either less than, greater than, or not equal yung ating magiging alternative hypothesis. Okay? So yan, after the null hypothesis, meron tayong level of significance and we do the computation. So after that, we have to create yung ating rejection or the critical region method. Okay, and that is determined by the two hypotheses, the null and the alternative, as well as the level of significance. That's why nga sa step 2, we have to write down kung ano yung level of significance, either 0.05 or 0.01. The region or the critical region predetermines the critical or the rejection region natin sa ating normal curve. And the rejection region is a range of values such that if the test statistic falls into that range, we decide to reject the null hypothesis in favor of the alternative, or we otherwise reject the null hypothesis. Okay, so with regards sa rejection, because before we can draw the critical region natin or the curve, so we have to understand first kung ano yung ating decision or yung ating test, I mean. Pwede ba siyang left-tailed, right-tailed, or two-tailed? Okay, Pag sinabing left-tailed, no, nasa left side yung ating region, ang right-tailed naman nasa right yung ating region. Okay? So, ayan, for example, this is a one-tailed test on the right. So, ibig sabihin, this is a right-tailed na test. Because yung ating critical region or the shaded region is nasa right side. Okay? So, ito yung ating shaded part. That is the rejection region. Okay? So, kung magkukompute tayo ng statistic or ng z-test or t-test values, pag dito siya mafo-fall, ibig sabihin nasa rejection region siya. So pag andito siya sa rejection region, we have to reject the null hypothesis. It's always the null yung ating i-consider, no, for the decision making, either accept or reject. Pag nasa shaded region, reject the null. Pag dito siya sa unshaded region, that is accept the null hypothesis. Okay? So that is the case kung right-tailed siya. So example dito, yung ating null is equal to 100. Okay? However, yung ating null is nasa gitna, no? I mean yung ating mean. So yung ating alternative is greater than. So ang greater than is nasa right side. So that's why andito siya yung ating shaded na region that is greater than 170. Kung left-tailed naman, so nasa left na side. Okay? So instead of finding our shaded region sa right side, nasa left side naman. So, ayan. So, yung ating null, equal, yung ating means, yung ating alternative naman, magiging less than siya because nasa left side naman siya. Pag two-tailed, okay, both ends yung ating may shaded region. Okay? So, merong sa left, meron sa right. And these are all equal. Equal to alpha or the level of significance divided by 2. Okay? Because symmetrical pa rin dapat yung ating magiging curve or ating normal area. Okay? So, ayan. So, ano ang ating magiging conclusion or decision later on? Okay, if we reject the null hypothesis, okay, so like I said earlier, kung magko-compute tayo and our values ng z or ng ating t nasa shaded region, ibig sabihin, reject the null hypothesis. Pag nasa unshaded region naman siya, that is, accept the null hypothesis. Okay, so if we reject the null hypothesis, we conclude that there is enough evidence to infer that the alternative hypothesis is true. So we reject the null, we accept the alternative. So hindi totoo yung ating null, yung totoo is the alternative hypothesis. Okay? If we fail to reject the null, okay, we conclude that there is not enough statistical evidence to infer that the alternative hypothesis is true. Okay? So, ayan, and this does not mean that we have proven that the null hypothesis is true. Okay? So, ano yung ating methods na normally ginagamit? So, for this particular video, focus tayo sa sample or population versus sample or sample versus population. We have two sets of data. Yung malaking data, the population, and the smaller group, we have the sample. Okay? So, kailan ginagamit ang z-test? Pag ang samples are larger than, equal, or greater than 30. And normally, this is the first criteria. Okay? We just have to look sa problem kung ilan yung ating samples, ilan lahat yung iti-test. Kung 30 or greater, automatically, zeta siya. Okay? Pag less than 30, 29 below, yung t-test siya. Okay? Then another criteria, the standard deviation of the population is known. Okay? That is when we compare sample and population. This is used to compare two means taken from the same population. Dapat same population siya. Okay? Kung ating population is all about humans, so dapat yung ating sample are also humans taken from the population. Okay? Hindi siya dapat magkaiba na group. Okay? So let's say kung humans, so kung male yung ating population, dapat male lahat din yung ating sample and exactly taken from the population yung ating sample, yung ating samples. Hindi pwede yung population is male Then female naman yung ating sample. No. Okay? So that is not sample population versus sample na Z-test or T-test. Okay? So dapat same population. Okay? Kaya nga sample because it was taken from the population or from the same group of individuals or research units. Okay, so sa mga attachments natin, we have the normal curve area, and this is the one we use sa ating normal curve na areas. Okay, so the same table, because this is the table for the different z-scores. Sa t-test naman, that is kung less than 30, that is the first criteria. And the population or the standard deviation of the population is not known, and it is used to compare means of independent samples or groups and the means of correlated samples. Okay? So, means ng independent groups and means of correlated samples or before and after. So, that's the coverage ng ating second and third videos. Okay, for the t-test, we have a separate table of values dyan. So we have, this is a screenshot ng ating t-test na table. So we have the DF or the degrees of freedom. Okay, so we have the values here. And then yung ating alpha can be found sa ating first row. Okay, so ito yung heading ng ating alpha or mga level of significance. And the levels or mga values are found sa baba. Okay? So, yung ating computation, okay, that is we want to compare sample with the population mean. So, we have the z value because this is the one that we will be computing later on, yung ating z-score. That is equal to our sample mean minus the population mean divided by the standard deviation of the population over square root of n or the number of samples. For t-test, same pa rin, okay? So that is sample mean minus population mean divided by population standard deviation or sample standard deviation divided by square root of n or the number of samples. Okay, so if we recall, yung ating population or ating sample na standard deviation is simply equal to the summation ng values minus the mean quantity squared and then i-add lang natin isa-isa. Then divided by n minus 1. Okay, ang ating degrees of freedom is always equal to n minus 1. Okay, so and this is our table ng ating mga decision making. Kung less than yung ating alternative hypothesis, the exact opposite of that is our null hypothesis. Okay, and so on. Okay, so yan, to illustrate, let's have a problem dito. As part of college entrance requirements, let's say that all first-year college students in General Santos City are required to take an intelligence test. The mean IQ score for all students taking the test is 108. The mean of a sample of 45 students from the Mindanao State University is 113. And the population, and the standard deviation of the population is 8.6. Is the mean of the college students from the Mindanao State University significantly different from the mean of all the first-year college students in General Santos City? And we have to test that for 0.05 and 0.01 levels of significance. Okay? So, ayan. So, we want to compare yung performance ng particular university sa kabuuan ng mga students sa city. Okay? So, yung ating city is General Santos City. So, lahat ng students yan, lahat ng first year has to take up the intelligence test or the IQ test. At ang kanilang mean score is 108. Okay. So, and then at the same time, sa mga nag-take, okay, merong 45 students coming from MSU Jensen, ang kanilang average naman is 113. Okay. So, we want to compare kung significantly different or hindi ba yung performance ng MSU compared sa kalahatan or sa buong Jensen, which is 108. Okay? So, let's write down first yung ating mga data. So, we have ang mean ng ating students na who took up the exam is 108. Ang kanyang standard deviation dito sa problem is 8.6. Ating sample naman, so 45 students yung galing sa MSU Jensen, ang kanilang average is 113. So we want to test kung ang 108 ba na mean sa lahat ng students ng Jensen is significantly different sa mean ng mga taga-MSU, which is 113. Okay? So yan. If we read the problem ulit, okay, yung question dyan is the mean of the college students from MSU significantly different. So hindi nag-claim na greater than or less than. Pag ganito yung statement, yung ating magiging alternative is simply not equal. Okay, because hindi siya sinabing less than or greater than. Okay? So kung not equal yung ating alternative, yung ating null will be equal because this is the present condition. Okay? So equal, ang lahat ng means is equal to 108. Okay? So lahat ng means ng IQ test ng students ng Jensen is equal to 108. So regardless kung saang school yan. Okay? Basta ang mean is equal to 108. Okay, however, ang Jensen naman is, ang MSU is nasa 113 yung kanyang mean. And yun yung ating alternative. That is a statement that we wish to compare, no? So, yung ating mean is not equal, okay, to 108. Okay? So, hindi siya greater, hindi less than, but not equal. Okay? Because ito yung sinabi sa problem. I-test lang kung not significantly different or different. Okay? So, yung ating null is not significantly different. So, equal lang yung mean. Then, yung ating alternative is significantly different. So, kung kanina equal, this time not equal because different na yung mean sa 108 na population mean. Okay, ang step 2, so i-state the level of significance. So from the problem, that is 0.05 and 0.01. Ang step 3 is to draw the critical region. Okay? So the first thing na gawin natin is to draw our bell-shaped na curve. So that's why dito we have the bell-shaped na curve. So this is the standard normal distribution na curve. Okay? Yung ating problem, if we look at the alternative hypothesis, not equal yung kanyang statement. Okay? Pag not equal yung ating statement, automatically two-tailed siya. Okay? So pag two-tailed, dalawa yung shaded region. Both ends of our standard normal distribution curve is shaded. So ang tanong lang dyan is what is the value of that shaded area? Okay? So kung sa 0.05 muna tayo, okay? So ang shaded area na yan is equal to the level of significance. Okay? So ating level of significance is 0.05. But since dalawa, because this is two-tailed test, i-divide natin sa 2. So 0.05 divide 2, that is equal to 0.025. So on the other, this is on the left side. Sa right side, the same pa rin, 0.05 divide 2 because symmetrical sila dapat. Okay? So that's why this is 0.05. So itong area na to is 0.025. Okay? So yung area na yan. Okay? But we are not concerned with the area. We are concerned kung ano yung ating value ng z-score na andyan sa baba. Okay? So if we recall our discussion on the standard normal distribution, particularly dun sa finding the area under the curve, okay? So ang given sa problem is the area. Okay, ang area na to is 0.025. Therefore, yung ating unshaded area, okay, yung ating white na area is 0.05 minus 0.025 or that is equal to 0.475. Okay, so yung ating unshaded area is 0.475. Okay, so if we look at the table, yung ating Z na table, so these are the Z scores. Yung area is nasa loob ng ating table. So this is the area. Okay, so we have to find the area na equivalent to 0.475. So yung ating area na 0.475, so ito na part, so that is equal to 1.475. 1.96. So that's why yung ating z-score dito sa baba is 1.96 negative kung nasa left side, then 1.96 positive kung nasa right side naman. Okay? So this is for 0.05 na level of significance. Pag 1% naman or 0.01, the same idea, okay, both ends because this is a two-tailed test. Okay? 0.01 divide 2, that is 0.05. On the right side, 0.01 divide 2, 0.005. Okay? So this is the area na nasa labas. Okay? So if we want to get the area na nasa loob ng ating curve, okay, or the unshaded region, so this is simply 0.5 minus 0.005, or that is 0.495. So the same kanina, let's look at the table kung saan yung value na 0.495. Okay? So saan ang 0.495? So if we can observe, walang 0.495. However, meron tayong 0.4949 and 0.4951. At ang value natin is somewhere in between. Okay? Or exactly in between. So that's why sa ating z-score dyan is 2.57. So in between siya ng 2.57 and 2.58. That's why our z-score is negative 2.575 sa left side and 2.575 sa right side. Okay? So meron na tayong dalawang regions. Okay? Ito sa 0.05 and yan naman is nasa 0.01. Okay? So yung ating values is negative 1.96 and positive 1.96 sa 0.05 and negative 2.575 and positive 2.575 sa 0.01. That is a third step, yung pag-draw ng ating critical region method or the ating curves, I mean. Step 4 is to compute the statistics. Okay? So yung ating z-score, ang formula, that is mean. Okay? So this is the sample mean minus the population mean divided by standard deviation over the square root of n. Okay? From the problem, our sample mean is 113. This is the scores ng taga-MSU. Minus the population mean, this is the score ng GenSan. So 113 minus 8 divided by standard deviation of the population, we have 8.6 divided by n. Okay, so how many yung ating samples sa population? We have 45 students from MSU. That is square root of n. So the answer for that is 3.9. Okay? So if we go back sa ating curve, ang 3.9, saan makikita ang 3.9? Yung ating 3.9 is nasa dito na side. So nasa shaded region siya. So ibig sabihin, this is nasa rejection region yung ating z value na 3.9. So the same, the 0.05, mas maliit nga yung value, 1.96. So the 3.9 value is nasa mas malayo na part. Okay? So in conclusion, since yung ating z na computed is greater than the z critical, yung ating sa critical region na area, so 3.9 is greater than 2.575. This is at 1% because mas malaki yung value sa 0.01%. However, mas malaki pa yung computed na z-score. And since nasa rejection area siya, so we have to reject the null hypothesis. Okay? So yung ating null hypothesis na nagsasabing walang significant difference is not true. So we have to reject that. So kung hindi siya true, therefore, there is highly significant difference because yung ating null sinasabi na there is no significant difference. However, mas nasa rejection area yung ating z-score. Therefore, there is a highly significant difference in the mean IQ score ng ating sample, which is our MSU students, compared with the population, which is the General Santos City. Okay, so that's how we solve problems using z-test. Okay, using our 5-step process. Ang step 1 is to state the hypothesis, the null and the alternative hypothesis. Number 2 is state yung ating level of significance. Number 3 is to draw our critical regions or determine our critical values, compute our statistic, and then step 5 is to make the appropriate decision. Okay, so para mas maintindihan, let's have another example. So this time naman, let's have a one-tailed na test. Kasi kanina we have two-tailed test, okay, na problem. Okay, so in this problem, the research meteorologist has been studying wind patterns. This time, mga wind patterns naman yung i-compare. And based on these studies, a new route is proposed. Okay, may bagong ruta that is for the commercial airlines going from San Francisco to Honolulu. The new route is intended to take advantage of existing wind patterns to reduce the flying time. So yung pinaka-purpose ng bagong route is to reduce the flying time. Okay? So it is known that sa old na route, okay, so ito yung ating population because this is the existing na route or the status quo. Ang kanyang flying time is 5.25 hours. Ang standard deviation is 0.6. Okay? So sa bagong route, no, 36 flights yung inobserve at ang kanyang mean is 4.90 hours. Okay? Does this indicate that the average flying time for the new route is less? Okay? So yung ating keyword dyan, less. Okay? Mas less na yung ating time sa bagong route compared with the old route. So let's write down muna the given. Yung ating population or existing na route, we have 5.25 hours yung flying time. Ang standard deviation is 0.6. Ang ating sample, okay, yung bagong route, nag-test ng 36 flights at ang kanilang hours is 4.9 hours. Okay? So what particular test yung ating gagamitin? Because this is greater than 36 or greater than 30, I mean. So this is a z-test na test. Okay? So going back sa ating problem, so yung ating gustong patunayan is less. Okay? The keyword is less. Therefore, dapat yung ating alternative must be less. Okay? So less than 5.25 hours ang population. Okay? And in this type of problems, we want to always compare yung ating population na mean. Okay? So in this case, sinasabi na less than 5.25 hours na yung bagong route. Okay? And we want to prove kung totoo or hindi. So that will be our alternative hypothesis. The average time for the new route is less than, okay? So less than 5.25 hours. Okay? Kung yan yung ating alternative, the opposite of that is the null. Okay? So anong opposite ng greater than, ng less than, that is greater than and equal. So ang average time ng old route, no? Or ang average time ng new route is not less than. So hindi siya less than 5.25 hours or that is equal or greater than 5.25 hours yung kanyang flying time. So the null and alternative must be the exact opposite of each other. Okay? So less than yung ating alternative hypothesis, therefore yung ating null must be greater than and equal. Okay, step 1, that is state the hypothesis. Step 2, state the level of significance from the problem, 0.05, yung binigay na level of significance. Step 3 is to draw the critical region. So, draw ulit tayo ng curve. Okay? So, sa problem, ating alternative is less. Pag sinabing less, mababa. Nasa left side yan or one-tailed test na nasa left. Okay? Because dito yung ating, this is the mean, nasa center ng ating curve, less than yung ating gustong patunayan. Okay? So, nasa less than 5.25. Okay? So, dapat andito siya. Okay? Because less yung ating alternative. So, ito yung ating gustong i-prove na area. Okay? So, less, no? Pag alternative is nasa less, left-tailed, no? No, one-tailed test. Pag greater than naman, nasa one-tailed test na right-oriented siya. Okay? So, sa problem less, so we have to go left. Okay? So, ito yung ating shaded region at yung ating alpha or the level of significance is 0.05. Okay? So, this value here or this shaded area is 0.05. So, yung ating unshaded area from 0 papuntang shaded area na boundary, that is 0.5 minus 0.05 or that is 0.45. So going sa ating table ng z test na table, okay, so walang exact na 0.45, however it can be found between two values which is 1.64 and 1.65. Okay, so in between lang, that is 1.645. So ayan, going sa ating graph or sa ating table or chart, so since nasa left side siya, that is negative. So z is equal to negative 1.645. Step 3, that is drawing or pag-create ng critical region. Step 4 is determine or compute our z-score or our statistic. So the formula is still sample mean minus the population mean over the standard deviation over the square root of n or the number of samples. Okay, so sa problem, ang new root na mean or the sample mean is 4.9 minus ang population mean, that is mean ng old root is 5.25 divided by the standard deviation 0.6 over the square root of n or the square root of the number of samples, which is 36. So the result is negative 3.5. Okay? So i-compare natin sa ating curve. So yung negative 3.5 is nasa leftmost pa. Okay? So dito somewhere yung ating negative 3.5. So makikita siya sa shaded na region or the area of rejection. Okay, so ang decision, since 3.5 is less than negative 1.645, ito at 0.05, reject. Okay, nasa rejection area siya. Therefore, okay, so kung nag-reject tayo, we reject the null, okay, and we accept the alternative. Ano yung ating alternative? Less than. Okay, so therefore, yung ating conclusion, the average time for the new root is less than 5 hours. So, totoo na less than 5.25 hours na yung ating new root. Okay? So, that's how we compare two sets of data, population versus sample, using z-test. And ito nga, sa problem natin, we always compare dun sa ating population. We use our population means as a reference value. So that's why yung ating mga means na ginagamit for step 1 sa pag-state ng hypothesis and then sa step 5 for the decision is always naka-base sa population mean. Because yun yung gusto nating i-prove na true or not yung ating population mean. Okay, so let's have another problem, the last one. No? This time we will be using t-test naman because ang first two problem is all about z-test. Okay, so this time let's have t-test. Okay, so problem, John works as a sanitation engineer for a zoo that has 10 elephants and 8 zebras. Ito yung laman ng ating zoo. May 10 elepante and 8 zebra. And every day he goes to work, he feels he is shoveling a great deal of waste. And he wants to know if the amount of waste that he disposes of on an average is different from the normal amount of elephant and zebra zoos dispose of. On any given day, ang nasa-shovel niya na waste is around 1,500 pounds with a standard deviation of 500 pounds. Okay, are removed from these facilities across the country. Ito pala, sorry. So, across the country, 1,500 yung 1,500 pounds yung nasa-shovel, ang standard deviation is 500. Pero si John, ang nasa-shovel niya is 1,700. Okay, so from the figure alone, medyo mas mataas. Pero statistically, mas mataas nga ba? Okay, so yun yung gusto nating i-prove. So yung tanong, is John shoveling more crop? Okay, so mas marami ba talaga siyang sinashovel o pinapala compared sa average ng national? Okay, so we have to test that one for 0.05 and 0.01 alpha. So ang first step muna, before the first step, let's write down the mga values. Ang population na mean natin is 1.5. So this is the amount ng lahat ng mga waste, no, on average na pinapala or sinashovel on the country. So on average, 1,500 pounds. Ang standard deviation is 500. Ang kay John, because si John yung sample natin, 18 times yung kanyang pagkuha ng sample. Then ang average, 1,700 yung pounds yung kanyang napala. So, bakit t-test? Because this is less than 30. Okay? So, sa problem kanina, okay, is dyan, okay, ang keyword more crop. Okay, so clear. So, gusto nating i-prove na more yung kanyang nasa-shovel. So, yung ating alternative hypothesis, mu is more, no, is greater than 1.5. This is the population mean. So, yung sinashovel ni John is greater than 1.5 or greater than the population mean. So, ang exact opposite niya is the null hypothesis. Pag greater than, so yung ating null is less than and equal. Okay? So, yan, that's how we state the two hypotheses. The null is less than or equal to 1,500 yung waste na sinashovel ni John. Pero yung alternative is we want to prove, no, na totoo ba is greater than 1.5 yung kanyang sinashovel. So we have to step 2, yung ating level of significance, i-compare natin sa 0.05 and 0.01. Okay? Then ang step 3 natin is to draw the critical region. Okay? So sa 0.05 muna tayo. Okay? So this is one-tailed because more. Okay? So yung keyword ulit, more. Okay? Pag one-tailed, then more siya, nasa right side naman siya. Because kanina, yung keyword na less is nasa left side. Ito, more than the average. Okay? Because the average is the line of symmetry na nasa gitna. Okay? So that is the average more than the average. So dapat nasa right side siya. Okay? So ang 0.05, let's look at our t-test na table. So this is 0.05. Okay? Nasa ating first row. Okay? So on the first column, merong hinahanap na DF. This is the degrees of freedom. Okay, the formula for the degrees of freedom, so if we go back dun sa ating formula sets, ang degrees of freedom is equal to n minus 1. Okay, yung ating n is 18 lahat, 10 elephants and 8 zebras, minus 1 is 17. So sa 17 na values, let's have the intersection dyan. So 17 and 0.05, that is 1.73906. So that's why yung ating t-score dito is 1.739607. Okay, that is kung 0.05. Okay, kung 0.01 naman, because dalawa yung gusto nating i-test na level of significance, so the same idea, no? So, same na degrees of freedom and 0.01 yung ating alpha. So, we have 2.56693. So, that's why sa ating 0.01 na curve, so yung P niya is 2.56693. 0.01 yung area. Okay, step 3, critical region. Step 4 is to compute for the statistic. Okay, so more or less pareho ang formula with the z-test except na nagkaiba lang ng may difference lang with how we define the variables. Okay, so this is still sample mean. Okay, ang sample is 17. Ito yung sinashovel ni John. Minus the population mean, the national on the average is 1.5 divided by S is the sample na standard deviation which is 500, ito kay John, na standard deviation over the N or ating sample size which is ang 18 or square root of 18. So the answer is 1.7. Okay, so saan makikita ang 1.7? Okay. So, going back sa table, as ating step 3, sa ating chart, 1.7 is andito. Okay, so nasa unshaded region. So, unshaded region is accept HO. Sa 0.01, andito naman siya. So, still accept. So, therefore, yung ating decision, since that P is less than 0.05, because mas maliit yung value sa 0.05, and 1.7 is less than 1.739 607, accept HO at all levels. Okay? So, i-accept natin na yung average lang ni John is not greater than, no, sa national na average. Therefore, based sa alternative hypothesis, John is not significantly shoveling more crop. Hindi mas marami yung kanyang sinashovel. More or less,
equal, no, or malapit lang sa national average. So sa values, hindi sila exactly equal. But statistically, yung difference nila is not significant. Therefore, parang sinasabi, pareho lang or magkapantay lang yung dalawang values. So ang conclusion natin, hindi mas marami yung sinashovel ni John. Okay? So, yan, that's it, no? An example of a t-test for population versus sample mean. Okay, for our next videos, doon naman tayo sa two types of different sets of data naman. We have two independent cases and correlated samples.